Welcome back. This is section 10.6, which is relative rates. And again, I can insist how important it is to start with reading your textbook, take a look at the PowerPoint presentations, and take a look at the solved examples, and then use this homework as this video as to help you with your homeworks. But if you start with this video and scroll back and forth just to get the solution for that problem, it is not going to work. Now that I said that, let's go ahead and take a look. Here we have, they say assume x and y are functions of t, and they're asking us to evaluate for dy by dt, and they gave us the conditions. They gave me dx by dt, they gave me the x value, and they gave me the y value. Now let's go ahead and work this out. So let me rewrite the problem here. I have 3xy minus 6x plus 4y cube is equal to negative 40. Now I'm differentiating with respect to t. Keep in mind this is one term and this is another. So I'm going to be using my product rule. And how does that work? I'm going to write down my first function. Differentiation of y is 1. But I'm differentiating y with respect to t, so dy by dt, plus I'm going to write down my second function. Differentiation of 3x is 3, but I'm differentiating with respect to t, so dx by dt. Differentiation of negative 6x is negative 6, but I'm differentiating with respect to t, so dx by dt, plus 4 times differentiation of y cube is 3y squared, but I'm differentiating it with respect to t, so dy by dt. And the differentiation of a constant is a 0. Now that I know, all I'm going to do is go back and plug these values into the function. So 3x is 4, dy by dt is what I'm trying to find, plus my y value was negative 1. Negative 1 times 3, dx by dt was negative 8, minus 6 times negative 8, plus 4 times 3 is 12, y is negative 1 squared, dy by dt is equal to 0. Now let me go ahead and simplify this one. 3 times 4 is 12, dy by dt. Negative times negative is positive, so 24. Negative times negative is positive, so 48. Negative squared, positive, so 12 dy by dt is equal to 0. And now that you see, I can combine my dy by dt's. I have 12 and 12. That give me 24 dy by dt, plus 24 plus 48 is 72 is equal to 0. Now all I'm doing is I am simplifying for, or I'm solving for dy by dt. So dy by dt, don't forget the 24, is equal to negative 72. dy by dt is negative 72 over 24, which is negative 3, and that is your final answer. But the clue here is make sure you write down your dy by dt, dx by dt, dx by dt, and dy by dt, because you're differentiating it with respect to t. All right, now let's go ahead and take a look at the next problem. This is a word problem, so it's important you read and figure this out in your mind, because not every problem is going to be the same, and I don't want you emailing me saying I don't have this problem in the test. Every problem is going to be different, and again, the concept here is to make sure you comprehend this problem and do these kinds of problems, not just this problem. All right, the radius of a spherical balloon is increasing at a rate of 0.6 per minute. How fast is the volume changing when the radius is 7.9 centimeters? To start with, volume of a sphere is 4 by 3 pi r cube, where r stands for radius. Now they're asking me how fast is the volume changing. That means I have to find dV by dt. But what's my V? Let me pull this down. My volume is 4 by 3 pi r cube. So 4 by 3 and pi stay the same because pi is a constant, times derivative of r cube is 3r square dr by dt. Once you have this, let's go ahead and plug in. Remember, you don't have to plug in anything for these because they are constants, and the 3 as well. You have to plug in for the r square. Actually, 3 and 3 get cancelled. So I have 4 pi r square dr by dt. Let's go ahead and see what information can we get. It says the balloon is increasing. The radius of the balloon is increasing 0.6 centimeters per minute. So my dr by dt is 0.6, and they're asking me how fast is the volume changing when the radius is 7.9. So my radius here is 7.9 squared. So let me plug this into the calculator. It's 4 times pi. Where is my pi? I can find it here. Okay, times 7.9 squared times 0.6 gives me 470, and rounding it to one decimal place, 0.6 centimeters per minute. And let's go ahead and compare that, and that's exactly what we get. All right, so the clue here is knowing that the volume of a sphere is 4 by 3 pi r cube. And once you know that, all you have to do is differentiate because they're asking you for the rate. Now let's go ahead and take a look at the next problem here. And again, this is very important. You start with visualizing what's going on. So I'll try to do my best to graph this one. Wish me luck here. A 7-foot tall man, this is going to be hard. So a 7-foot tall man walks at 7 feet per second towards a street light. So a street light, how do I do that? Street light. Okay, street light. Let's make sure this is the ground, so we all know that's a ground. And let me pull the man all the way down. Good. And the street light is 15 feet above the ground. Okay. At what rate is the end of the man's shadow moving when he's 13 feet from the base of the light? Okay. So this is the street light. It falls here. So the shadow of the man, honestly, I don't want to draw the man. So what I'm going to do is I'm going to copy him. And I'm going to paste him here, and I'm going to flip it. So that's going to be the shadow. Oops. Actually, he's not straight, but okay, that's going to be the shadow. Okay, let me redo it. I'm going to paste it. And I'm trying to make sure the shadows match. There you go. Pretty much, yeah? All right. So this is a street light. It falls and it casts a shadow right here. So what they're asking me is, use the direction in which the distance from the street light increases as a positive direction, okay? And they're asking me to find at what rate is the end of the man's shadow moving when he is 13 feet from the base. So the man moves. Oh, I need his head too. So the man is I need his head too, don't I? Why do I have so many heads here? Okay. Okay, let's try this one more time. So when the man is So when the man is moving, the shadow also moves. As you can see, the man moves, the shadow moves with the man. So what they're asking me here is, if the man is moving towards this direction, at what rate is the shadow moving? So from the edge of the man to the street light, let's just say this distance is S. And let's just say this distance is X. And we already know that as X changes, S also changes. And we've seen that, right? When S is changing, oh no. When S is changing, X is also changing, right? Okay, now how do I solve this one? Let me go ahead and make sure I have a triangle here. This is the height of the man. And if you look closely, does this replicate similar triangles? So this is 15 feet, which is the height of the lamppost. This is 7 feet, height of the man. And these two are similar triangles. So let me change the colors here. So this is one triangle, right? And this, another color. This is another triangle. So we have similar triangles here. So how do I work when I have similar triangles? So I want you to go ahead and see what I'm doing here. 15 over 7, that is this side over this side, is same as S, which is of this triangle, and this distance, if this whole thing is different color again, if this whole thing is S, and if this little piece is X, then this distance is S minus X. So if you see, I have similar triangles, similar sides. Once I have that, this becomes easy peasy. And again, knowing that this is a similar triangle is very important. So let me go ahead. And again, I'm differentiating it with respect to time. So what I'm going to do, I don't like to differentiate it here because it's too much for me. I'm going to simplify this. So I'm going to cross multiply. So 7S is equal to 15 times S minus X. 7S is equal to 15S minus 15X. I'm going to bring all the S's to one side. What do I have? I have negative 8S is equal to negative 15X. The negative cancel each other. And I have S is equal to 15 over 8X. Now see the magic. All I'm trying to do is I'm trying to find the distance that the shadow changes. That is this distance, the S. From the edge of the shadow to the lamppost. I'm trying to see the rate of change of S here. So I'm differentiating ds with respect to time. dt is equal to 15 over 8. Differentiation of x is 1 dx by dt. Now you might say, Miss, we have nothing here. No, we do. So I do know what dx by dt is from the problem. Remember, x is the distance that the man is moving. And we do have his speed. What is his speed? 7 feet per second. So all I have to do is 15 times 7 divided by 8. And that is going to give me, again, keep in mind they're talking about the distance. And here they say, use the direction in which the distance from the street light increases as positive. So this direction is going to be positive and this direction is going to be negative. So anything that's decreasing is negative. Anything that's increasing is positive. So here, when, let me see, when the distance, let me take this off here, boom, this is gone, 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 and this is gone, and this is gone. Let me bring back the head. So here, the distance, I think I'm going to cut off his feet. So as you can see, when I move, what's happening? The distance is decreasing. Do you see that? So decreasing distance is always going to be negative. So 15 times 7 divided by 8 is approximately negative 13.13 feet per second. That is negative because it is decreasing. Okay? All right. Let's go ahead and take a look at the next problem here. It says, suppose that for a company manufacturing calculators, the cost, revenue, and profit equations are given by the cost, the revenue, the profit, where the production output in 1 week is X calculators. If production is increasing at the rate of 500 calculators per week, when the production output is 4,000 calculators, find the rate of increase or decrease in the cost, in the revenue, and the profit. So what they're saying is, hey, I am producing more calculators, so definitely the cost is going to increase. Now help me find out if my revenue is going to increase or my profit is going to increase at 500 calculators per week, where the production output will be 4,000 calculators. So let's go ahead and write down the equation. Let me copy this here. C, the cost is 80,000 plus 20x. And let me write down my revenue here. My revenue is the calculator revenue is 300x minus x squared over 20. So I'm finding the rate of change of the cost. I mean, I don't have to do differentiation. Of course, if I'm increasing the production, the cost is going to increase, but let's just prove it using derivatives. I'm differentiating with respect to t. So differentiation of 8,000 is a constant, which is a 0, and differentiation of 20x is 20 dx by dt. And I know dx by dt is the rate of calculators produced per week, which is 20 times, what is the rate of calculators produced per week? 500. So times 500. So this is going to be 10,000. So the cost is going to increase by 10,000. And that's what I have, increase by 10,000. Now let's look at the revenue. dr by dt. By default, if you're a good businessman, you will not just see the increase of the cost, you will also see how the revenue is increasing, because you just don't want to be producing when you don't make any money, right? So derivative of 300x is 300 dx by dt minus 2x divided by 20 dx by dt. Remember, this is the revenue of the calculators produced per week. And I have dx by dt as 500 minus, this is divided by 10. And the x is the number of calculators produced, is 4,000. We have it right here, 4,000. So I'm going to go ahead and write that down. 4,000 times dx by dt is 500, the whole thing divided by 10. So this is 150,123 minus 20,12345, but I'm only going to have 4. 1, 2, 3, 4. So 20, no, I put the comma in the wrong place. So 200,000 minus, that gives me negative 50,000. So my revenue is going to decrease by negative 50,000. And it is decreasing by negative 50,000. Now what about the profit? Profit is simply revenue minus the cost. My revenue is decreasing by negative 50,000. My cost, subtract my cost is 10,000. So my profit is negative 60,000. That means I am at loss if I do this. All right, let's go ahead. Again, if you have questions, you can rewind, pause, and do it based on your speed. So let's go ahead and take a look at the next problem here. A manufacturer of handicrafted wine racks has determined that the cost to produce X units per month is given by this equation. This is a quadratic equation. How fast is the cost per month changing when production is changing 15 units per month and the production level is 80 units? All right, so we already done something before. So let me write down C is equal to 0.4x squared, plus 7,000. And they're asking me the rate of change, dc by dt, with respect to time. So 0.4 is a constant times 2 times x. Don't forget dx by dt. Derivative of a constant is a 0. So let me go ahead and plug in 0.4 times 2. And now let's go back. The rate is 15. So my dx by dt is 15. How many units am I producing? 80 units. And if I multiply all of this, I get exactly $960 per month. That's the cost. Hope this helps.